Okay, so as you can see, here's the pages from our Chapter 2 review, and the book does a pretty good job of highlighting what the key vocabulary words are that you should know. But also with each section, 2.1 goes over fractions and estimating products and quotients. And Chapter 2 deals with the multiplying of fractions and whole numbers, or multiplying fractions and fractions. As again, it does a pretty good job highlighting the steps you want to take to be able to do these. I know that this one here is a little bit different than what we do, so let's take a look at this with an example as to how we do it. They tell you to multiply the whole number times the numerator and you keep the denominator. Ours, it acts the same way, it does the same thing, it accomplishes the same task, but when we did it, let's look at 5 6 times 9. We talked about when you write a whole number as a fraction, it's that whole number over 1. And so that's 5 times 9 is 45 over 6. Okay? Which is exactly what the book says to do anyways. The book tells you to multiply the whole number times the numerator, 9 times 5 is 45, and put that over the denominator. So what we do is no different than what the book does. The book just explains it differently. Now what I want to do is I want to back up here though, because there's something I didn't do, and you might have caught it. And the only thing I didn't do is I didn't cross cancel. And 6 and 9 share a common factor of 3, so 6 divided by 3 is 2, 9 divided by 3 is 3. So 5 6 times 9 is 15 halves, which is equal to 7 and 1/2. And don't forget, when you're taking the test, I will accept either of those two answers as correct. It's just that if you didn't simplify, then I'm not going to take full credit. And all this is saying is that 5/6 of 9 is 7.5. Okay, then there's the multiplying fractions. And remember, multiplying fraction is the easiest thing we'll do all year. It's numerator times numerator over denominator times the denominator. And since the numerator and the two numerators are factors, and any numbers that multiply together to give you those two numerators are factors, and same thing with the denominators, we can do the cross-canceling where we look at our diagonals, numerators and denominators, and we check to see if they have any common factors, such as this one here, 3/10 times 4/5. Well, 4 and 10 share a common factor of 2, divided by 2. Now we get 3 times 2 is 6, 5 times 5 is 25. And if we didn't cross cancel, you'd get 12/50, which would simplify down to 6/25. Okay, multiplying mixed numbers. Same thing as multiplying fractions, except the only thing we don't do is we don't multiply by a mixed number. We take our mixed number and we go ahead and we make that into an improper fraction. Improper fractions, denominator times the whole number plus the numerator. 6 times 1 plus 5. 6 times 1 is 6, plus 5 is 11. 6. And then 2 and 3/8. 8 times 2 is 16. Plus 3 is 19/8. And they're not being very nice to us. We have nothing that we can cross cancel. So we get 11 times 19 over 6 times 8. Well, 6 times 8 is 48. 11 times 19. If you're not quite sure, can't do it in your head, and I'm not expecting you need that you would do it in your head, you go off to the side. 11 times 19, and 190, and you get 209. And there's nothing wrong if you kept the work on your paper, but 209 over 48. And then if I want to change this to a mixed number, don't forget 209, 48. 48 is almost 50. 50 goes into 209 4 times. So 4 times 48, don't forget our distributive property. Let's see how 4, if 4 is enough. 4 times 48, 4 times 40 is 160, plus 4 times 8 is 32. So that's 192, so that is more than enough. So it goes in 400, and then 209 minus 192 is 17, 17/48. Okay. Moving on. Dividing fractions. Dividing fractions is the same thing as multiplying fractions. The only difference is that we don't multiply the fractions, we multiply by the reciprocal. Oops. I want to get my highlighter. We multiply by the reciprocal of our fraction. Okay, so we take our fractions. Let's do this one over here. 8/9 times 3/10. Another way to write that is the 8/9 times 10 over 3. And we're not cross-canceling anywhere. 8/9 times 10 over 3, because we take this fraction and flip it over. We get 80/27. Then 27th goes into 80 3 times. Is that right? No, that's 3 is 81, so it goes twice with 26/27 remaining. Same thing as multiplying mixed numbers. First thing, write each mixed number as an improper fraction, and we multiply by the reciprocal of our divisor. Cross cancel if possible. So 4 1/8 divided by 2 1/4. Don't skip a step. You remember I told you if we skip a step what happens. So it's 33/8 divided by 9/4. Don't forget to write this division expression, then change it to multiplication. 33/8 times 4 over 9. We can definitely cross cancel here. 4 goes into 4 once, goes into 8 twice. 3 goes into 9 3 times, goes into 33/11. We get 11/6, which equals 1 5/6. Okay. Moving on, fractions as decimals. This is the easier of the two. When you have a decimal, you identify the place value of the last digit. So tenths, hundredths, thousands. If you need to on your test, write out a multiplication, or a place value chart. That's 155 thousandths. Not only is it 155 thousandths, but don't forget, it's 3 and 155 thousandths. So the key to writing a decimal as a fraction is to write it as you would read it. This is 3 and 155 thousandths. We're going to come back to that. This is 8 hundredths. This is 24 hundredths. And that's 6 tenths. So you would write the fractions as you would read them and then simplify it. So 155 and 1000, they're both divisible by 5 because they both end with either a 5 or a 0. So this is equal to 3 and 31/200ths. And that is the best we can do. Okay? Alright, and then the last type is when you change a fraction to a decimal. The two methods that we went over, one was the equivalent fraction method, and the other one being the division method. Equivalent fraction works some of the time, such as 29 3/5 is the same as 6 tenths, which as a decimal would look like this, 6 tenths. But the equivalent fraction only works when the denominator of a fraction is a factor of one of our powers of 10. The other method that works all the time, we'll do number 32 with it, is the division method. Don't forget, your fractions are written in numerators divided by denominators. So when we do our division, it's numerator. Oops, it's not numerator there. It's numerator divided by denominator. So in the case of 7, 6, the numerator is 7 divided by 6. I recognize right away that this fraction is over 1, so my answer better be greater than 1. So we put our numerator there, decimal point, add a couple zeros. I always go with 3 to start. 6 goes into 7 once. 1 times 6 is 6. Subtract. I get 1, bring down the 0. 6 goes into 10 once. 1 times 6 is 6. Subtract. I get a 4. And don't forget, once you move your decimal point up to the quotient line, it's there for good. You don't have to worry about it. There's nothing that you need to do with that decimal point underneath. It just stays there. You don't need to carry it down or anything. Just leave it alone once you bring your new fraction up to the quotient line. Okay. Get back to the division. Bring down another 0. 6 times is 36. Subtract. Oops. Get 4 again. Bring it down. I get 40 again. Guess what? I get 6. I'm going to have a 6 again. 36. So this one here, we see that we have a pattern going. So 7, 6 is equivalent to, is the same as 1.16. And the repeating bar, the bar notation goes over the 6. And that's how we know that it is the 6 that is repeating. So there you go, quick review right from the review section in our book on how to go over how to do multiplying fractions, dividing fractions, converting fractions to decimals, and decimals to fractions. All right, and that's the end of the video, and good luck on the test.